Good evening and welcome to Mechanics of the Fourth Wall. Joining myself and Antonio Suberetz tonight is Cami Nodal. How you doing, Cami?
Oops, good now?
There you go.
Really good, Nathan. Really good. Sorry with trouble with the mute button, but good now.
And how are you, Antonio?
I'm having trouble with the mute button too. I'm very well, thank you very much.
Superb. Well, this is going to be a light-hearted conversation, which has got me in trouble before we've even started based on the title. So Cami's already told me off and said, look, you put the pressure on before we even started. So to clear the air, this is going to be a usual Mechanics of the Fourth Wall show. It's unscripted. There's no pressure to produce anything or show anything or tell anybody anything. So that's out of the way. So Cami, I want to ask you a few flat Earth related questions, though, if that's okay.
Go ahead.
Well, what do you think the shape of the world is?
Well, I think it's flat.
Really? Well, that's
Really?
a shock.
No, that is something that I do believe. I mean, not flat, but we are not on a ball.
But why do you think we're not on a ball?
Why do I think I'm not on a? Because I've been studying it for over a year, and it's ridiculous. I mean, every aspect of it is ridiculous. So we're past there, but.
Is it because you can see things that are way too far to be seen on a ball?
It is because I can see things that are way too far to be seen on a ball, and it is because looking at the stars, I'm supposedly seeing things that would be way too far away to actually even see in millions and millions of light years away, and just day-to-day observation on how it works. If you step away from the learning and trust some basic observation, you'll see you are not on a ball.
Do you ever have any of those kind of disquiet moments that happen to some people when they come into the flat Earth, when they wake up and realize that the world is flat, where they get like a sense of urgency, thinking, oh my God, maybe I'm being deluded? Do you get any of those?
I may have had it over a year ago, but I've been in this for quite a long time now, and I've moved past the proving it's not a globe to trying to figure out exactly how it does work. But I think at the beginning I had them, but again, the more you look and the more you look at all of the different facts and use your observation and common sense, just common sense.
Yeah.
I don't have those any. I doubt a lot of things are real, and I have different things where I do think I might crazy about this or I might crazy about that. But as far as not living on a ball, it's been like over a year since I've had one of those. Maybe I'm crazy moments on that.
So when did you find out?
I went all in. Pardon?
When did you first? You said you've been doing it for 12 months, and we all obviously already know the background to that. But how long have you known that the Earth was flat, or when did you find out?
I'm not so good with timelines, but thinking about. It was something my husband brought up. Again, it's been well over a year now. How long do you think it's been?
About 15.
15, 16 months. Basically, he came up with like, what do you think? Do you think the world could be flat? There's some information up on YouTube in that, and I was like, no, I don't think it could be flat in that. And I started thinking even again, and it comes up, it's funny because then you watch all the videos and it comes up, but I was like, what can I do to like prove? And so we looked at some of the different flat Earth maps then and that, and it's like, what wouldn't work? And it's like, well, reality wouldn't work. You wouldn't be able to travel on this map. You wouldn't be able to, a lot of things could not happen on this map. So I went to prove that traveling didn't work, and then I learned all about flights on the southern hemisphere. That really got my attention, and then again, the more I started looking into it, the more ridiculous it seemed, and then we started following. We have a son named Jaron, and there was a channel up there called Jaronism, and we may have all heard of Jaronism. And so because it was so similar to our son's name, we started watching him a lot, and he wanted to do a laser test, and it's like real science, real ways of looking at it and proving it. And at that point, we decided to buy him a laser. And that was how we got in touch with Jaron and met him. And I think the rest is pretty much documented in history.
Did Bob lay it on you as bluntly as that then? Did he literally just say, do you think it's flat?
Bob lays a lot of things on me just like that. I think he's in the background right here. Yeah, he's like, what do you think the possibility? And again, your initial reaction is that's the most retarded thing I've ever heard, and there's no way it can be. But again, when you actually stop and look into it and quit, just going off of the cuff of it can't be, and you look into the facts on it. And again, he went into it, and I went into it knowing this because, again, we share a house, we share a room, there's videos playing. He was very, very much into disproving NASA, or not disproving NASA, but knowing that NASA is lying to us and wondering why. And this would be like a good answer to that. But we came into it already being like researching a lot of things. We'd been, I'd personally researched vaccines. He'd been doing the space. He's been doing everything since I've met him, just on researching. We're curious. I tended to research more through mainstream, where he would do, which, this would be like an off channel, but we're both very curious people.
Well, you've spent the last 12 months, as you've said once already, looking at this. And when we last spoke on Skype, and that got published under the same title, How the World Works, you explained that you'd kind of stayed out of the online hangout scene in favour of actually researching. Could you tell us a little bit about how that kind of began?
Okay, that began this is very uncomfortable for me even being here. Everybody can't be everything. So everybody finds their little pieces on there. So in this, I support my husband in doing Globebusters, and we definitely follow all of that. In the meantime, I'm very much my own person, and I'm a curious person, like I said. And so I started saying, well, if we were on the flat Earth, how would the sun and the moon work, and how, and I'm looking at all of the different videos, and I'm looking at all of the different maps, and I think it led me to, like, first of all, the Gleason's map, which I have behind me, Antonio has behind you.
Yes, I do, right.
I loved that map. I loved the Orlando map. That was the dish one.
Yeah.
We all know the Orlando Ferguson map.
Yeah.
So they had several things in common. I spent, I don't know, the first few months looking at all of the different maps and seeing what I liked and I didn't like. The Orlando Ferguson map was my favorite just because of the beauty of the map, but it had a lot of the same problems that the globe has. That how does water curve up here, curve down here? If we're measuring it flat, does this make sense as far as the physics go? And I'm a very logical person. That map and the map that we have behind it, I'm looking in and zooming in on you, Antonio, and looking. But the Gleason's map totally intrigued me. It's absolutely wonderful, the way that it works in time, the way you look at things, and the more you look at the world, the more you start seeing it in time instead of as a entity, or I don't even know the right words to describe it, and I'm circling on your map, Antonio. But you see it, as very real, and the more you study time and the more you study distance, so you start looking at the nautical miles, the regular miles, the cubics, the different, sets of measurement, and you learn that measurement was all based on time, and they started changing the definitions even of what measurements mean and adding in your English miles in that to distance it away from time. Now, the Gleason's map incorporates time in it. It's the Ferguson map incorporated time into it. They both have anomalies on it. You have where areas of the map are out of time, but they incorporate time into it. And then you look at, like, the Gleason's map behind you and say, again, so much of it is real, but what's not real? What's not real, and if you point to it, Antonio, because I have you up.
Yeah.
What's real about it? It's real. It's an equidistant map. Meaning that everything on the map is equidistant, and the distances are correct on it, or somewhat correct. I mean, I've found some anomalies, but with getting rid of the anomalies, it's very correct. Yes. And then I can bring it up.
One thing that I've noticed that is definitely not correct is the area of illumination, of sun illumination, on the December solstice and the June solstice.
Right.
Now, I've done a drawing of the actual illumination. But we'll talk about this later.
No, and it's fabulous because it's within the things that the anomalies that are not correct that you have to say, like, try to find what's real. The main thing that I find that's not correct, and I'm going to pull a map down and, oops, is in being, oops, do we have it? In being an equidistant map, it means that distance has to equal this distance.
Mm-hmm.
That doesn't match reality. Reality does not, you cannot measure, you cannot put any type of distance when it equals this. In reality, distance has to really equal size. And so it's like, this map is beautiful, you have some anomalies out of it, but what doesn't work, and the obvious reality is, you know, this is, Australia is not this big compared to this. I mean, the size,
Yes.
in order for this map to be correct, what you'd have to do is you would have to open up each one of these wedges and make them perfectly rectangular. But of
Yes.
course, if you do that, you can't pull them on the map correctly.
Yes.
So
what,
it became a puzzle to me.
with
It became,
with the way of establishing an azimuthal map, okay, where you have this pinching at the north and splaying as it goes out towards, you know, Antarctica. You have this correction of landmass size,
right.
which is why we have such a small Eurasia, and then such a big Africa compared to Eurasia, and such a big Australia compared to Africa, and all of these distortions, because they're using something that is not actually reflecting reality. The real world does have continents spread around, but if you don't actually measure the distances, the width of those continents and the distance in straight lines from those continents, and nobody can actually measure the actual distance in a straight line between these continents, then you're going to use a projection, which is what the azimuthal projection is. You imagine how things might be lying down, and then you draw them. And then, to make them fit, you establish how time works in this drawing that you've projected. But the real world is slightly different. The real world has real landmass, which is fixed and not dependent on who's deciding to make an azimuthal. You know?
Exactly.
So I'm going to step in and boil this down to make it much more simple. So in other words, what we see in terms of taking one step forward should be scaled down to taking whatever unit of measurement forward on the map, and it should be as simple and as straightforward as that. Whereas, as Antonio's just nicely put it, you have this pinching at the north and splaying at the south in order to make that particular map right, which is exactly the same as the azimuthal equidistant projection, is it not?
Exactly. Yeah. And it is that. So you have it. Again, it's a beautiful, the way that it addresses time, the way that it addresses different, it's scientifically pretty accurate, but it's not reality accurate. And that's your difference between your science and your reality is that, yeah, scientifically you can travel, you can mark distances and time on it, you can mark distances even for mileage as long as you make each one of those blocks equal the same, but in reality this is not this. And
so let me just, you've given a brilliant example. Okay, if people can look at what I'm showing with my fingers, okay? Nathan, if you fix the camera on me. Let's say that this portion, this distance here, which is just under an inch as I'm holding it, let's say that that represents, say, 1,000 miles, okay? In that case, this area here, which is twice that, okay, you see that's like 2 inches, also equals 1,000 miles. Yeah? If this is 1,000, then this, all of this, is also 1,000. That's the idea behind a projection. And like Cami has said, it's a mathematical, it's a scientific, which is a mathematical way of establishing correspondence between the real world and the world of science, where science doesn't actually know the answer and wants to arrive at something that it can say, this is what the answer is. They use mathematics. That's it.
So 12 months ago, Cami, I think from memory, the way you phrased it was, Bob said, we live in an electromagnetic world, and you took that very much to heart. Is that correct?
I would I don't know if it happened. I'm looking at him. It's like I don't know. I think he was looking heavily at the electromagnetics and explaining, and I believe he like maybe I don't know. It was never phrased like that. There was never that conversation never happened just like that.
Yes,
But the interest went on how it could happen, and he brought me into the electromagnetics and thought he believed that, and then I went. I loved it. I loved the magnetic world. There was a lot to learn, a lot to take in, a lot. But it was real. It's real science, not. I was trying to think of that too. Real science takes place every single day on a practical level, every day, and it's real. And there is good science that takes place in all types of things. And what I believe they're doing is they specialize out the sciences so much. They branch them down so much to separate them, and that was something I was going into too, is even the separating of terms on different scientific levels, that one term means in one set of sciences this, while in another set of sciences has a whole different meaning or a whole different phrase. So if you have somebody that's a scientist in one division reading into another division, they'll assume the word means the same in that science, and even though it will work in the paragraph, it has a whole different meaning on how you would grasp it.
Yeah, so an example would be of science that's used every single day outside of the lab. Okay, this is just a very simple example that I'm making up right now on the spot. When we're driving, okay, we are using observation to determine how fast we're traveling, so the speedometer and how fast things are moving, and the distance to the vehicle in front, and establishing whether it's safe or not if that vehicle had to suddenly brake. Okay, this is the purpose of science, and that's how science works. It's based on real observations of the real world. We then have the compartmentalization, where you have the real experimental physicists who work with equipment other than just the brain, and there's nothing wrong with the brain, but equipment who can test and verify what they study. And then you have the other department of physics, which is theoretical. And these guys don't use equipment. These guys ask the other guys to verify what they're thinking about. You know, can you set something up to see whether what my idea is right or wrong? And that's how it works. And between the two, there's an area where you have the experimental physicists that veer towards the theoretical and will use models like mathematical models to try to describe things that their equipment is showing. Now, sometimes it corresponds absolutely, but often it doesn't. It doesn't actually correspond absolutely. So they will use words to say we can approximate, and barring if we include the normalization, after normalization, X, Y, and Z. Okay, so you can have a phenomenon that has a regular dynamic, and this regular dynamic points to, say, infinity, like a vortex that has no reason for stopping. They can't use infinity in an equation, so they will normalize it, and instead of talking about time and how long something can sustain itself, they will talk about output of energy and normalize this, so they can say, they can direct away from something magical thinking like infinity and refer to something that they can actually establish after a normalization process, which is when they bring in a limit so that it sounds correct.
So would you say, Cami, that normalization, would that be the kind of term that you were talking about then, where it has different meanings and different, or was there another specific term that you were thinking of?
There would be that they do the normalization. They would be like, for instance, I'll bring it into a field I know, and even how it's touched into flat Earth and what I know. What I did before this is I worked in a jewelry store, did a number of things, but one of the things I did was gemology and gem ID and that. And so in real science, I did for the city and county of Denver and for the different things, you have to assign, you have to look at rocks and know what's real, what's not real, and assign a value to them. People die, you need it for estates, you need it for purchases, you need it for insurance, you need it for all kinds of legal reasons. And so the science of gem ID, for instance, is a very, like, real, oops, we're off. I'm off. I lost you, Nathan.
Okay. He's okay, yeah.
Okay. So the science of Gem ID, that would be an idea of daily science that, I mean, I have a refractometer, I have a polariscope, a microscope. I even at home have most of this equipment and I play with it still on a regular basis. And you do little science experiments. You take, somebody has a ring that's got a light blue stone in it and it's like, wow, this could be commonly one of 10 things by looking at it. It could be, if you take it to the opposite scale, another 20 possibilities, you know, for rarities will pop up on it. But you're looking at something that's, you know, light blue, and it's like, what is it? What dollar amount do I put on it? And you have to look at it, and you have to say, you know, is you take a refractive index. You say, hey, what angle does this stone bend light? Does it break it up into one beam, two beams? You know, what's your birefringence? You have your little terms. What's the specific gravity on it? Does it fluoresce? You take all the little tests. And then you say, you determine from there. And then once you even determine from there, you have to look at it and say, now, was this grown in the ground or was this grown in the laboratory? Now, this is where, like, for instance, what you're saying, the terms, how do they do? Now, the term synthetic, what does synthetic mean to you, Antonio?
Artificial.
Okay, Nathan, what does synthetic mean to you?
Created.
Created, okay. Now, in gemology, gemology has got a very, very specific term for what synthetic is versus simulant is. It's a legal term. In gemology, synthetic means it is exactly the same material. Lattice structure, chemical composition, everything about it is the same, and the only differential is that it's grown in a laboratory. So a synthetic diamond is an actual diamond that's grown in a laboratory instead of in the ground. Synthetic ruby, all of you are different. Everything can be made synthetic. If it's, you would think it would be artificial and not the same, but I mean, it has to be identical.
Yeah.
So what you're saying is if you had a certain rock that had other impurities and you cut them out right down to the point where what you were left with was absolutely pure, that would be classed as synthetic. Is that what you're saying?
Not at all.
No.
I'm doing a bad job explaining. Not at all.
No, I've got you. So if something was created in a lab and it was absolutely indistinguishable in terms of its actual inherent qualities from something that happened naturally in the real world, one of the two would be synthetic, even though the two are the same thing, serve the same function, behave the same way. The one that was created in the lab is synthetic, whereas the other one would be natural or whatever the term is for a real, original kind of earth-made diamond or whatever.
Right. And I mean,
the label that's given to anything that's been created not in the ground, if you like, then.
But it's not just created not in the ground. It has to be the exact same. It has to be, you know, corundum being sapphire, or it has to be chemically the same. It has to have all of the same qualities, every single same quality. And the separation of it, you actually take classes called separating sophisticated synthetics. Sometimes you can't do it. Labs spend weeks doing it because they are so good at growing them in laboratory. This is like, so in gemology, what I know is I know crystals grow. I know we grow them in laboratory all of the time. I know that they're an ongoing growing. I don't think people see rocks as what they are, or crystals, but the term synthetic is in gemology, meaning it's the identical substance. The identical substance created, not just something that's made to look like it. A simulant is something maybe done in a laboratory or poured glass or something made to look like something, but a synthetic actually means it has to be identical.
So have the actual qualities, the same qualities.
Exactly.
The same qualities.
Index and things like that.
But you're taught to. So when you look at the word synthetic in front of diamonds or in front of emerald or in front of any type of thing on it, the rest of the world is taught to think synthetic. Oh, it's just fake. You're not even thinking about. In other words, that word synthetic is completely tainted to you unless you're in this world to mean something totally different, and so you can be fooled by it. I mean, because just like in the United States, it's illegal to. They grow, I mean, they can create, I don't know if you know this, and they can actually create gold, they can create platinum, they can create, in laboratory, all of these. Gold is created from mercury and irradiation of mercury in this. You're not really told this can happen with the minerals because, like in the United States, they make it illegal to call anything that's not grown in the ground a mineral. You can't legally put that term to it, so you can't you can't say even a synthetic mineral because of the fact that they don't like. The only way you can label these substances are by their chemical formulations. You can't say it's the mineral.
So
It's a game.
Could you say synthetic gold?
No, you cannot, because as soon as you get into
Gold is the
that,
mineral.
you're talking about a mineral, and you're not allowed to assess or call something a mineral unless it's grown in the ground. And so you get into little legal. I mean, I'm saying that it's deceptive out there. It's crazy.
Mm-hmm. Yeah.
And it's always about the words and their tricks and spells, and it's magic.
It's magic. And so when you see or even look at like no trees in the forest, or the different things that you guys are working on, however it's called, if you look at fossilization and petrification, for instance, it does not happen. You can go and read the articles. It doesn't happen over millions of years or 10,000s of years. It's happening all of the time. Things are turning into rock daily. If you go to Yellowstone, trees there are actually soaking up the silicon-enriched water, petrifying daily, and dying off at the top of that. And there you would have a natural silicon tree, for instance, but it's not something that's happening millions. It's something that's ongoing.
Yeah. So what they've done, the sciences, or at least geology, has said, like we were saying before, they normalize things and they shift away from what they're describing. So if they said petrification happens, and it can take, not very long to very long. Once it's petrified, okay? Then it sounds a bit wishy-washy. It doesn't sound very scientific if they say that. If they say some petrification takes a few months, another petrification, we don't know because it's freaking petrified. It might have taken a few months and then remained petrified since then. So that doesn't sound scientific. So instead, they give this, table of petrification ages ago.
But it doesn't agree with in laboratory. In laboratory, I actually have some of these articles I could point out, but they've done petrification in 2 days in laboratory, and they've done fossilization in under 2 weeks in laboratory. It has nothing to do with the time frame. It has to do with the conditions present. Yes. And they flat out say, they tell them, I mean, there are article after article saying that our science does not match our story.
Yes. So this is exactly
that's real science. I mean, that's real science, that they can petrify in 2 days and they can fossilize in 2 weeks in laboratory under putting conditions on. That's real science, telling us that things happened millions and millions of years ago, and that fossilization happens, which is turning into stone. Petrification happens, which is turning to stone. Stones that's just part of the natural cycle. It's not something that, again, happened millions of years ago and go into the caverns, go into a lot of places. Things decay, life happens all around.
Yeah, and no, like, I've noticed this from doctors.
I think we have a slight problem with our live feed. I'm just checking it, and it seems to have completely frozen. I'm just going to check on YouTube.
It's buffering from my point of view, as I'm looking at it now.
I'm just going to have a quick check on YouTube, see if it actually works.
It's fine.
What the chat feed is saying, possibly not.
Nathan, it's fine.
Is it all okay?
Yeah.
Okay.
It's got you and me discussing how whether or not it's working.
Oh, right.
So.
Okay, and I don't have any of that stuff up in here. I'm just, I have enough screens already.
It's fine. It also showed me, whilst looking, that my hair looks dreadful. It's not very sexy. So.
I didn't know we were going for the sexy look today. I'm sorry.
Just got back from the park. Patricia and I went for a stroll in the park. It was lovely. So it was. So back to the scientists and doctors. I've noticed with doctors, they have this aversion to saying the words, "I don't know." It's like they have a huge problem. They will, struggle. And I've seen this with many different doctors, eye specialists and all kinds of different doctors. In fact, they have terms that say from unknown cause. They have a very clever sounding term, which means don't know what's causing this. Okay? And you say, so what's causing this? They say, oh, well, this is, don't know what's causing this.
Mm-hmm.
And you go, oh, right, okay. And you go home, you know? And then if you check, you go, that just freaking palmed me off. It's like arthritis means aching joints. You know, it's like, oh, okay. Well, I just went to the doctors with aching joints and said, what is it? And the doctor said to me, you've got aching joints. Like, yes, I know, that's why I freaking came. Can you tell me what's causing it? And like, they don't say, I don't know. They say, well, this will help it. Take these painkillers. So it's all a freaking con. We live in a world where the pirates actually run things. You know, we have this idea that established governments with suits and ties, all respectable, and pirates hundreds of years ago were these nasty, nasty people who went around robbing and raping and burning, and those pirates are the guys who now run the world. That's what those pirates did. That's how we have so many lies, so many corruptions. It's because the guys that run the world are the pirates. So yeah. I wanted to ask you, if we go back to when Bob said to you, do you think the world could be flat? Okay. And you said no, but then you started looking at it. Do you recall what you first looked at? The first thing that you thought, okay, I'm going to look at this and weigh up sphericity versus flatness. Do you recall what your mental process was?
I do. I know the first thing that I did was because I did it to my style. I took a string. I took the globe, scissors, string, and that, and started mapping off distances on the globe between cities. And I actually had to have, I mean, I took yarn or, you know, a twine thing to do this, and actually mapping off different things and saying, sweetheart, this isn't going good. I'm going to. It's like I'm trying to prove this is ridiculous, but things aren't right. Yeah. So I definitely started with flights, because to me that was, you look at different things and things that you can actually measure, and flights were something that people get on the planes, they travel, they arrive at their destination. So it was something that it seemed like a practical way to go about it.
Yeah. So distances. Like I did exactly the same thing. I measured distances, Ushuaia and other places, Santiago de Chile, and all the typical things.
All of the things, yeah.
I noticed Google Earth says something. Okay, fair enough. There's a rendering trick with Google Earth. I don't know if you've noticed. You know, you can click
your distances. Yeah, they change. They change a lot on you.
They generally do this with Google Earth, depending on what they require to show you, okay? Corresponding to the globe, not to the real world, corresponding with the globe, okay? So with any physical globe, you can check whether it's correct or not, because that's not going to warp. For instance, if you have ocean to the left of the globe and you're spinning, okay, on a physical globe, the next landmass that you come is going to come as you spin, okay? But with Google Earth, they can just carry on spinning and now bring in the landmass, okay? So with a physical globe, I started checking physical globes. They are all different. And my globe-ling friends said, oh, it's because it's difficult to print something round. It's like, they would say it's difficult to print an atlas onto something round. And I said, well, if you have satellites, they have 3D printers. They could print an absolutely exactly correct map, including all of the contours. They could include all of those, okay? But all the globes are wrong. When they're not wrong here, they're wrong there, because the world is not a globe, and you can't put the Earth onto a globe and have it be correct.
That's right.
Yeah. So you started measuring distances between places, and you started to say, hold on a second, this is wrong. Yeah?
Exactly. This is wrong. And we worked to that. Then looking out of it, it's like, well, if the globe doesn't work, and then looking at the Gleason's map, and it's like, well, this works really pretty well, but it's not real. What does real look like? And so I know there's like talks out there on the map and it not being important, but some of us are curious. And even though I think the important thing is that we've been, deceived, and I think it's important that everybody stays, on the track on what is wrong on it. Some of us just aren't meant to go there, though. Some of us just have to be, I can't dwell on what's wrong. I want to know, I want to learn things.
Yeah.
It's, instead of studying what's out there and being, oh, they lied to us, and I know they lied to me. I know.
Well,
I
they
have
lied to each other. This is the thing. They also lied to each other.
Exactly.
So, I don't think that the heads of astronomy departments and the heads of geology departments know it's flat.
No, I don't think so at all.
I think a few might, but they're not going to discuss it at some astronomical society meeting. That's not going to happen.
Although, what about Airy? I mean, he was the astronomer royal.
Yeah, well, this is the thing. When that happened, this guy had honor, and he discussed this experiment, and he did it, and it failed to show, spin of the Earth. So he had integrity, and he discussed this, and he got into like fisticuffs with people who were either telling him that he was lying or that he'd done it wrong. So it was a big deal. Okay, so like many people who have integrity or who embellish their integrity, who dress with their integrity, when somebody says you have no integrity, that's when they become kind of violent, So anyway, apart from having failed to show the spin of the Earth,
is it worth a quick boil down of Airy's failure?
Do you know what? I think could you guys do that a minute? Because I need to check just to make sure my son's being picked up today. So if you want to do this, I'll be back in 1.
No problem. Yeah.
Sure. Do you want to do it? Or do you want me to do
it? Yeah, okay, I'll do it. No, you do it.
Well,
no,
we'll both have a bash, because I remember being quite early into flat Earth, and I work in a supermarket. Well, I don't. I actually work out on the road delivering, and this one day I happened to be working in the supermarket, which I never ever do, and I just ended up chatting to some of the staff, and one of the guys was telling me that he was doing a university course in, I think it was geography, and I kind of had almost too much of a wry smile on my face, and he was like, well, what are you smiling about? And I was like, yeah, I've got a recent interest in geography. And he's like, well, what? And I was like, oh, no, I can't possibly tell you. And he eventually eked it out of me, and I told him, well, the world isn't as you know it, the world isn't a globe. And that obviously went on to it being flat, and that led on to explaining Airy's failure to him. And while I was explaining it to him, I just sort of watched his eyes glaze over as I explained what Airy's failure was. So I think, oh, should I do this? The last person I explained it to almost fell asleep while I did it. So maybe I'm not the best person.
Okay, Cami, do you want to explain Airy's failure?
Absolutely not.
Okay. Airy's failure is kind of simple and ingenious. You have a telescope. You're looking at the stars. You want to determine whether the stars are moving across or whether you are moving across. Okay, so either the stars are moving or you are moving. Okay, because there's motion of the stars. That's irrefutable. This is definitely the stars move. Okay, so how can you determine whether it's you or the stars that are moving? And he figured out, well, if I'm looking at the stars and I'm moving, as I move, where the star is, respective to the lens, will move as I move along, okay? But that's if I'm moving. If the stars are moving and I'm static, then the same would happen, but the other way around on the telescope, okay? So he thought, okay, to verify this, if I lean the telescope over to give myself a bigger allowance, and I fill it with water, the light, as it enters and makes its way to the lens, will take a little bit longer. So it gives a better allowance, a better margin of error to observe. And this is what he did. And what happened was, he leaned the telescope filled with water, and as the ether, you see, they were actually looking to see whether or not there was an ether causing anything. Now, if we're spinning within the ether, or if the ether is moving around us, then the ether within the water, within the telescope, will help move the light across as it enters the telescope, and this is what they found. So it failed to show that we were spinning. Instead, it showed that the stars are spinning and could be caused by the ether. At the time, they wanted to drop the ether, and they did. Eventually, the ether was dropped and eventually replaced it with relativity, special theory of relativity, and the other one, special theory. Anyway.
But my understanding of the experiment itself is that once he's filled the telescope with water, if the Earth is moving, the starlight that's entering the telescope will be travelling slower. Therefore, he will have to compensate for that by angling the telescope more. What he actually found was, regardless of filling the telescope with water or not, the light entering the telescope still went in exactly the same path. Now, had the Earth been moving with the telescope angled, once the light enters the telescope with the Earth moving, the light slows in the water, as I say, and you'd have to compensate by changing the angle of the telescope, which you didn't have to do. It didn't make any difference. Filled or not filled, the light still went in and was saw through the eyepiece.
Very clever way of determining which is which. And we have to think, this guy figured out how to establish which is which. You know, at the time we have Sagnac and Michelson-Morley and all these people thinking, how can we figure stuff out? Which is what's really fascinating about the real sciences. People have a phenomenon and they want to figure out how to figure out what the phenomenon is manifesting. That's, you know, so sit there and scratch your head. How can we figure out whether we are spinning or that is spinning? And it's fascinating. It's brilliant. You know,
I mean, that experiment has sort of been expanded out into the Sagnac and Michelson and Morley. But I mean, with that in mind, we know we're not spinning. This is absolutely certain. We definitely don't spin. And with that in mind, for the last 12 months, Cami, you've gone out and looked at the moon and its travel across the plane of Earth, and sort of come up with some pretty amazing conclusions in terms of how it works. Have you not?
I think I have. I mean, with this, I love, by the way, that was a great job on the experiments. I am familiar with all of them, but I'm not, again, you guys did a great job explaining them. I'm more of a doer than an explainer. What I have been doing is I've been going out every day, pretty much religiously, if that's what you want to call it, and looking at...
It's a cult. It's a cult. Sorry.
It's a cult.
Just had to say it.
Sorry, but what I've been doing is watching the actual movements, and I've always watched the sky, and looking at this, just how science says the items work and how Flat Earth says they work, and again, people watching the sky. I think I think I know what's happening. Is that arrogant, or is that?
No. No.
Not at all. In other words, from practical, I have a way of what I've done is I have gone out every day and have seen, I'm sorry, I have toys. Like I've joked with some people on here, I've spent an unusual amount of time in the bathroom on the floor with flashlights and balls trying to recreate and do moon phases. And so what I've been doing is looking at the scene, like the map behind us. It doesn't feel, again, it has really good qualities. It doesn't have real, if you do live on a flat Earth, things have to work some way. Mm-hmm. And so I've been trying to figure out a way that they work, but not employing magic, only employing like things that are really of this Earth, how they grow, things that I can observe and touch, feel. Again, no theoreticals in it. I have some hypotheses, but I don't have any theoreticals.
Yeah, things you can experiment with.
Exactly.
Yeah.
And so one of the things I noticed is that, and again, I do not. Can anybody explain how my moon phases work? Well, are you able to explain it better than I am, Antonio? Because
I think if you start explaining it, you'll do a really good job. I can explain it too. But I think it would just be better for people, and better for you, actually, if you start to explain it. And I pick up anywhere where you're lost for words or whatever. I really do. Okay. But if you want, I'll explain it.
Okay, well, we'll start off with saying that part of the things I've noticed is that, again, everything that they expose us to separates us from it. And I think most of these things would be obvious if we weren't hidden from it in a different type of way, meaning that our calendars being 28 days here, 31 days here, a 12-month calendar, if they actually had a 13-month calendar of 28 days and then added an extra day every year on it, I think everybody would have figured out exactly how the moon works and how the sun works and that, because you would see that it does the exact same thing in time.
And who changed the calendar?
Why, the Catholics did.
The bastards. So go on, sorry.
Okay, we're going to go on the Catholics, and I was raised Catholic, by the way.
Me too.
You too. I have not practiced Catholicism, but I was born and raised Catholic for it. I have a strong belief that it's probably not the Catholics as much as the elites, meaning there are elites within the Catholics, there are elites within every group, within the Masons, within that. And I strongly believe it's like the elites versus us, and that within any group that you could name, any subgroup that you could name, you're going to have certain people at the top that are elites, and the rest of the people are really good people. Again, whenever you take one group, I see evil and good in all people.
Yeah.
But that's off topic a lot. I'm sorry.
No,
So
not at all.
avoiding how the
such a
moon
mechanics
works.
topic. So definitely the good and evil being within all of us, as opposed to the God and devil being outside of us. Man, that's so mechanicsism true.
Yes.
And I love that too. And within each subgroup, again, every person has got good and evil in them. You're right. You're right. We fight it every day. So with this, I think that they separated. I mean, again, they put things in so you don't look at it. I read comments where people are like, "I saw the sun and the moon out on the same day," and at the same time, and it's like you see that all month long. I mean, it's the long summer days, especially in the daylight. You're going to have that a lot. If you actually look at time, if you look at the sun, what noon is supposed to be is noon is when the sun is overhead, right over your head.
At its highest point.
At its highest point
that it's going to get. So because you might be very far north or very far south, so it's going to be at an angle. I'm not doing a sea Kyle. It's going to be at an angle, and that's the highest angle that it's going to be. It will have come up, reach that point, and then start dropping down. That's noon. That's midday. If you were under the circuit of the sun, then it would be over your head.
Exactly.
Yeah.
Okay, but on the noon is where, again, in the 24-hour cycle, it's going to go around and come back to you. Regardless of where you are on the map, 24 hours later, it doesn't matter how long or short your days are, unless they throw something like daylight savings time and do things that change the maps. Where the sun is at its highest is 24 hours later, every day.
Yeah.
It doesn't, on long days, it doesn't change. On short days, it doesn't change. So is that like really clear that if you are on a perfect calendar and in your world, if you're right on where the middle of your time zone, your noon and the way it was meant to be, and that's why you'll see whoever did the countries, I think Antonio or Nathan, one of you guys did countries and time zones. You'll see that a lot of the Middle Eastern countries have little 20-minute time zones, and that what they're doing is they're aligning their like temples and that with with natural time.
Yeah.
So natural time is that. Now, midnight is very special. Midnight is the only time you will have a moon in your sky at midnight. If you're not on daylight savings time, and again you're on a real time thing, the only time you'll have a moon directly overhead at midnight is the full moon. So you will never have a quarter moon up at midnight. You will never have 3/4 of a moon up at midnight. You will, at midnight, if it is at its zenith, it is a full moon.
And if it's not a full moon, it won't be at that point at midnight.
It might be at that point at 9:45 in the evening. It might be at 9:45 in the morning. It's going to work itself around, because what the moon is a calendar, and again, it falls behind. It travels a little bit slower than the sun. People can, do how many minutes or that, but if we took you on the map, you can see that, every 28 days is its path. And so it falls away from the sun like a complete rotation in 28 days.
Yeah.
So the moon tracks the moons.
the month.
Months, yes.
The
And so
moon.
you would have, I mean, and we're taught that 13, and somebody even put a video on it. It's funny, everybody is thinking the same. I think that was Marty Leeds. But they said that we've even led 13 into being an evil number.
Yeah,
13
well,
is unlucky.
yeah,
13 is naturally the number of months you would have if you had it, if you kept, and again, if you kept track on an easy calendar, which would be 13 months of 28 days, an added
yeah.
day a year on there. Again, you would notice that all of these things are happening at the same time. But I think they say they don't want a 13 months in a calendar because it's unlucky. It's because you would start to associate time and distance and what's going on.
So with 13, unlucky for some, yes, and very lucky for people who have things like shields, coats of arms with 13 arrows and 13 stars and 13 all kinds of stuff, because they understand numerology, and 13, to have 13 of anything as an emblem, or your mind on 13 nurse, is supposed to represent guaranteed success. Okay, which is why King Louis the whatever, who rounded up the Knights Templar, chose Friday the 13th. That's why he didn't think, oh, I'll go for an unlucky day for me. No, he said, I'll go for a day that's pretty much guaranteed that I'll succeed in what I'm doing. So this whole 13 and hiding it and saying unlucky, that's just a way of just trying to divert people's attention away from things that can reveal truths about the world.
Exactly. And again, and on a calendar, to do it, it would make more sense that you're, regardless of what religion and that, to fall like right in season and right with the same patterns. Again, you'll notice you have to adjust it. It's a little bit, again, our calendar is very confusing. It makes it so you take it out of time. It makes it that you don't have the full moons or the half moon on any normal. It takes it out of its cycles. So now, if you were going to like put them back in their cycles and how they work, though, and think like really how they would have to do, and if you're on a flat Earth, and how they would have to circle around. And again, I really wish one of you guys would explain it better than me.
I'll explain it if you like. If you want to show it, if you want to illuminate the moon, and I'll explain what's happening, what the illumination is being caused by.
And I don't even. Do you think it will show up like that, or here? First of all, on it, the sun, as we're talking about in the model and through the seasons, it's going to work very much the same as people picture it on the Gleason or the Flat Earth map. Because again, my map will be similar, very similar to that, just changed enough to account for differences. So it's a
tweet to correspond with real distances rather than mathematically projected distances. Yeah.
Exactly, and it's just the main difference is you're basing everything on magnetics and how you would read direction. So that's, again, just a real way of looking at it. He took it. I'm going to. We're going to try to do this. Okay, so if you had your sun, which
I'm loving this, by the way.
You're loving this.
I'm really loving it.
Okay. So in season here would be your.
Can you hold it a bit higher? Can you prop your knee on your chair?
I can.
And prop it on your knee?
Yeah, let's see what we can do on.
Yeah, cool.
Is that working?
Yes.
Okay. So you would have, right now, you have, summer going into the different seasons. So your sun is going to flatten it, spiraling out. Oops, sorry, on the spiral. And you guys cannot see it, but it's higher here, spiraling, and getting lower here. And then spiraling and getting higher here. So those patterns, that makes sense, right?
Yes.
So why it's pathway doing it is just it's a flattened spiral.
Yes.
Okay? And I say one thing and do the motions backwards, but I need you to follow what I'm.
Yeah.
Does that make sense? So lower, spiraling, coming out.
And this is the sun or the moon for people?
That is the sun. So it's on a flattened spiral. The moon is dancing around the sun. It's the same with the other planets doing it. But the moon, why it's oops, put our map back. sorry, we'll do things. But so you have your sun, and your sun is going on the straight one. The moon within that is on a monthly pattern, doing an angled, basically an angled tilt on it, and so that's basically controlling. I'm using the word basically. I hate that, but it's essentially creating the moon phases by the height of the moon next to the sun and what I believe is a fluorescent reaction between the two.
Yes.
So I like this term. You described it as teeter-tottering.
Teeter-tottering. Okay.
Yeah.
And that's about right. Why going around it, so it's higher and lower, and these numbers, they're put out. I like to look at it in the science pages as percentages and angles and things to try to work it, because I'm trying to extrapolate backwards on it. But they will actually in science say that this is where the moon appears closer than the sun. This is where they'll give you the information, because there are real scientists looking at it, and it really does appear that way, and they can't be told differently.
Yeah. So a question, and this for me, is the sun higher from the surface of the Earth as on its outer circuit or on its inner circuit?
It's making somewhat of a toroid pattern on it, but the outer is where it's actually, I show it's closest on the outer side and higher at the inside from the angles that I'm looking at.
Right, okay.
And again, people look at it, add to it and do that, but that's what I see.
Cool, cool. I've been thinking it might be the other way around, simply because we've been told that when it's the southern summer, the sun is slightly closer to the Earth. Okay.
Right.
And I know that they just lie. So maybe they've just totally reversed what's actually happening. So the sun could be more distant from the surface of the Earth in the southern summer, which means that its reach of illumination would be wider. That's just my little personal thing.
I have looked at it. I've looked at it both ways, and I'm not ready to say on it until I get some distance modeling and seeing what the reaches are, because you're right, it does change the amount on it. And so until I can, get a little bit further, I do not rule out anything being reversed on it. But you're right, they do give when it's closest furthest and that. Yeah. I am relaying it, and I do know that they flop data on us a lot. So that's why I say I'm really open to everything while working on it.
Yeah. So between the sun and the moon, we have the sun on its circuit and the moon on its circuit. They're not tracks like on a circular excaelectric track, where they are both on the same plane, as if they were both on a plate. Okay, they are different tracks. They have the same circuit, the same kind of width to those circuits, okay?
Yes.
But it's not on a plate. It's not a line on a plate that they both follow that same line, okay? So you have teeter-tottering that you've explained.
You have the teeter-tottering, and you have what I like to call a spirograph pattern, that the circles are similar, but
yeah,
it's almost like, again, they're complementary, but they do not lay right on top of each other.
Yeah. So when you have the full moon, the quarter moon, so the waning quarter, the new moon, the waxing quarter, the full moon, these points you can graph, you can basically explain with the motion of the sun and the moon, not completely removed from the solar system, the spherical Earth model that's so gibberish that everybody, even globelings, go to look at eclipses and go, huh, that's strange, the shadow's coming from the wrong direction, I was expecting it to come from this, and then they just write it off. So in the real world, which is where we live, the moon is illuminated not by the direct light of the sun, but by a source which comes from the sun's direction. So
correct.
There's an energy that emanates from the sun's direction that reaches the moon. There's a stone that happens to illuminate when it interacts with a certain radio frequency, a certain range of radiation. What color does this type of stone irradiate? What color does it give out?
It gives out a chalky white yellow tone on it on one of the stones. looking at, yes.
Yes, but doesn't it go through phases? There's the bluish, there's the yellowish, there's the yes. So
you're jumping to celestite, yes. You're jumping to us, and let's see.
This is what you showed us last time. Is this a fairly accurate representation of this teeter-tottering?
Yes.
Okay, so we have to sort of give a bit of a disclaimer then. So what they picture it with on my very, very low-res picture from YouTube that I've just pulled up from our videoed on a phone hangout. Yeah, you've got this in the middle. I don't know if it's probably not showing on my screen share, but in the middle you've got what looks like a globe. You have to take that as being the North Star as opposed to the globe. And yeah, then you've got obviously the flat plane mapped out beneath it, and that would be covering all of the sort of milky white area. But yeah, but that's what you showed us last time. Would you still say that's a good way of showing it?
I think it's a perfect way of showing it, and if you guys can walk through even where the phases are on this, I can try, but if somebody can touch the screen and do it again, I visualize the things, and explaining them sometimes is not my specialty. So
Nathan, if you can fix, you were displaying by the way on YouTube, if you can fix the camera so it's displaying on you whilst Cami and I are talking, or even whilst you and I are talking. Cool. So if we were to take that globe in the center with the axial point of kilter, like we're told the globe is, and we just completely remove that, and instead under these circles, like we can interpret these are circles, okay, they look like very kind of flattened ellipsoids, but they represent, we're looking at circles from an oblique angle, okay. So let's say that under these circles was a map of the flat Earth, and those circles would be directly above the equator, and they move from the equator to the tropics, especially the sun. From the equator to the sun, it widens out to go around the Tropic of Capricorn, goes back through the equator, back to the Tropic of Cancer, slows down, speeds back, goes back out, and just does this continuously.
That is our year, yes.
Yes, that's it. Now, the moon is doing its circuit too. So if you go back to your camera, Nathan, I don't know if you're still on the camera, on your picture, but so you have at one point full moon, at the opposite point new moon. Between those 2 points, so let's say in that diagram where those 2 rings cross over. Hey, Jaron, how you doing?
Somebody's home from school. Fine,
yeah. Cool. So, cool haircut, dude. Nice.
You're on the air.
Yeah, I'm aware.
Yeah. Tell him I say cool haircut.
Cool haircut. Oh, that's right. He can't hear. I have the headphones on. I'm sorry. Barely. Okay.
Cool. So, where those 2 rings intersect, or where it looks like they intersect on that kind of angled perspective of these 2 circles, that would be the points of the quarter moons. What we call quarter moons, even though what we're seeing is half of the moon lit. Or, from our experience of the moon, we have a round thing and half of it lit. Okay? So, in different cultures, they refer to this half-lit moon in different ways. In the West, in English, we call it a quarter moon. Okay.
Which is confusing. You're right, because you see the half moon and we call it a quarter, and it's again part of.
Yes, it's to tell you there's another quarter on the other side that you can't see because it's a ball. Yeah. So you're only seeing a quarter of the ball lit up. Yeah. So what Nathan had showing is basically describing the actual motion of the sun and moon over the flat Earth, not around a globe Earth, over the flat Earth. Because the truth is, if you were to consider that around the actual globe Earth, it doesn't work at all. Because the sun doesn't spin around the Earth on the globe model, on the normal solar orbital mechanics. The sun does not spin around the Earth every month, and the Earth spinning on itself with the moon spinning around it doesn't portray this extra ring of the sun, okay? And this extra ring of the sun would have to be a corkscrew ring. It's just gibberish, but it works very well if you take the globe that was in the center of that picture and flatten it out into a flat map of the Earth with those rings over the equator. There you go.
There you go. I think you did it well, and it does. It works out. It works out incredibly well. It works out perfectly as far as I've been able to find, because what I've been doing for over a year now.
Sorry to interrupt. The chat feed just said it froze for the last 5 minutes of conversation, which is pretty bad news.
Okay. Well, it's showing to. Maybe it was
keeping an eye on it. There is craziness afoot, unfortunately. So my apologies for the technical difficulties if you're watching this live. How well it will go to the archives, I don't know, but it's going well for us. We're enjoying ourselves.
Yes, if I were you guys, what I would do, anybody out there who's got the kind of computer that can capture what your screen is showing, and I'm talking to you guys there listening, set it up so you can record the YouTube and the sound, because I wouldn't put it past some strange gremlin to just delete this whole thing before it actually goes up on Nathan's channel. Things like this have happened before. It happened when Nathan had Matt Powerland, did it not?
It certainly did. A very, very important show. And I would say, I mean, I might as well take this. This may never make it to archive. Who cares? But it doesn't matter to me. I've really, really enjoyed chatting to Cami thus far, and I've been anticipating this conversation, this show, if you want to call it that, for ages, and been on tenterhooks the whole time, because I'm just so excited to talk about the real progress that Flat Earth is now making. And it's with the nicest people, the positive people, and in the case of Cami, right here, right now, the hard-working people. You know, it doesn't take. It takes a lot of tenacity to go out night after night after night and track that moon and make sure you're, watching it and thinking about it and scratching your head and looking for the standard explained, the standard explanation that's available. I know you've had to do a huge amount of digging to get there, Cami, but you found stuff that makes sense, that works, that isn't a kind of an azimuthal equidistant projection. It's so exciting.
It is. It's exciting for me. I mean, it's exciting and fun for me. It's something I enjoy doing a lot. And
I love chatting with you anyway. It's just fun. Even when what we're doing is we're plotting what all the other flat earthers are going to do in secret. When that's what we're doing, plotting what we're going to direct them all to do. I'm joking. We don't do that. We just chat sometimes. Sometimes not even about the flat Earth. Just other stuff. But going back to the moon, that's the circuit it turns, the sun turns on that circuit. Now the illumination that arrives at the moon, this is what you figured out by lying down in your bathroom with the lights off, with a torch and a bulb.
Yes. And
Yeah, because you see, we've always had the model of the lunar orbit shown to us remotely. What we've had shown, and what everybody has had shown about the orbit of the bodies, the celestial bodies, has always been remote. Okay, you have a ball Earth and the moon. So we're not on that Earth. Okay, we're somewhere out in space. You have this Earth and this moon, and somewhere this sun, and this is happening. Okay, that's how we've been taught to visualize and conceptualize of the orbiting bodies. Now, to see it from the surface of the Earth, okay, there's an example with somebody holding a ball and turning like this, but they break away from certain key points where it shows that the orbital mechanics is totally wrong, like when she's here and you can see the sun and the crescent moon, and these people here, they might see the crescent moon, okay, at twilight, but not these guys way after twilight, okay, but you do see that crescent moon way after twilight, okay? So it doesn't actually work, and they shift camera angles to hide this. But anyway, what Cami has done is placed herself on a flat surface and said to herself, if I'm going to describe and figure out how it works, I'm not going to do it remotely. I'm not going to put a picture of the flat Earth and say the sun is here and the moon is here, and then kind of explain what it would look like from this point looking up at the moon. What she's done is she's laid down and said, okay, I'm the surface of the Earth. Let's see how the moon works. Let's see how the faces work looking up at the moon, which is how we see the moon. We see the moon looking out towards the horizon and up. So that's what you did. And you figured how it works, how it's not actually illuminated directly by the sun's light, how the height difference helps with the faces. All of this is cool. It's really cool. Do you want to explain?
I can. Thank you for it. The phases, yeah, laying on there, it's fun because it came out, it works perfectly, and it was too easy in a way. I mean, I think we try to overcomplicate things, but it really, you have the diagrams in there showing where it looks like the moon is higher and where, you know, the sun is higher. And if you sit on the floor and if you do like real experiments in practice, you'll find that like if you take it from the underneath, lay on the ground, take any like ball and flashlight, which I know it won't show up here, but if you do it from the underside and look at what you have by moving it up and down, you actually from underneath create all of the phases perfectly. But not only perfectly, if you look at and see, like if you take it on the drawing and see your distance, where you're supposed to be on the map, and you do that on the floor, you get the perfect, what you look up at the moon.
Yeah, so you get the full moon at the midnight point, the equivalent to solar moon. Mm-hmm. You have the lunar noon. No, that doesn't work. The lunar zenith. You know, at that point, at the highest point in its arc across your sky, when it's the full moon.
Right, and every crescent and every phase of it, if you take where the moon's supposed to be according to days, and again, if you put that calendar back up, Nathan, or not that calendar, I call it a calendar in a way. The
rings.
The rings, because it is I mean, everything's a calendar. But if you take it and make it so that each quarter, you know, the moon lags behind another 1/7 between each quarter, and you physically see what angle it's supposed to be on the little grid, you model it, it works out fine. I'm not a good modeler. Anybody is welcome to model this, but I cannot find any flaws in it as far as moon phases. People say that, I mean, the problems I'm getting with it are the people that are saying that you should be from the angle seeing it, you know, the different angles you're seeing it. Any problems I've had don't take the law of perspective where you're looking at the sky coming down at you and the ground rising to midway. Any perspective issue I've found with it just does not take perspective into it.
Right.
So I've not found any practical problems on it. But if you draw that, and again you start the moon one area, Nathan, and take it so the moon falls back again 1/7 between each quarter, you can create every phase perfectly.
Yes. Now,
and to me, that's a simple model.
Just so people understand this, okay? We're not saying.
I think so. I'd love your help. Sorry.
As far as I know, okay, unless I've got this wrong, remove from this image the globe from the center and place there the pole star if you want, or place the pole star higher. It doesn't really matter. We're not talking about the pole star right now. But anyway, you have a flat Earth map, okay, under these two rings. Now, I'm not sure, because I've not thought about it long enough, whether these 2 points, where the ascending and the descending, those points, I don't think that they're fixed in the sky. I don't think I might be wrong. I think that they turn.
Of course they do. They spirograph.
Yeah. Okay.
It's all in motion.
Yeah, so for anybody who wants to criticize and say, oh, well, you didn't mention that this is actually spinning, it's like, no. We're kind of interpreting that you understand that if we're talking about the sun and the moon over the flat Earth, that both the sun and the moon are turning, and that these points are also turning, okay? Well, we're not condescending. We're just trying to explain things best we can. If you would tell Bob, Cammy, I don't know if you can hear, that the Gleasons behind you is not actually straight. I just know that it will really niggle him. So.
Okay, hold on, Bob. Antonio wanted to let you know that the Gleasons behind us isn't straight, and he thinks that will bother you.
You're a real
that was
bugger.
Bob's arm.
Yes. So let's
He's in here
talk
cleaning
about.
up his office after me. I'm pulling the things off of the. I'm going to have to set up my own office because I come in here and take over his.
Yeah. So Cami, now
Yes.
let's discuss.
Mm-hmm.
First, let's discuss where you think and where I think. The two of us will discuss. And we haven't spoken for a while about the actual layout of the land masses. It's been a few weeks, okay?
Mm-hmm.
Prepare for the feed to just die.
Pardon?
Prepare for the feed to go wrong.
Oh, right. Okay. Okay. So let's see where we concur and where we might differ. Okay?
Okay.
On where the actual land masses are. And after we've said where the land masses are, we will have a reference where you can talk about the nodal points or the vortices or the poles. Do you know what I mean?
We're going to do that on a different show.
Are we?
Yeah, because that all in itself is, and I didn't bring any of my stuff to lay out or anything. Remember,
Oh, okay.
I said I would not be able to because I don't have any of the maps on this. I don't have anything loaded for that.
Okay.
I can jump in if you want to show where yours are and do it that, but I don't have anything to show right now.
Well, I haven't. What I've been doing is I've been working on basic landmass and tropics. That's what I've been working on. My map, which is really rough. I'll show you now in a
I want to
minute.
see.
It's basically based. I have two. One of them is crappy, and I was going to be drawing whilst we spoke. I said, I mentioned it before we went live.
The one looks great, actually, Antonio.
Which one? The bigger one?
The one that you showed, the sun and the. Well, I'm going to have to say it. The daytime, nighttime.
Daytime, nighttime. Okay, I'll show you then. When I can find it. Oh, so what I've been doing is basically working, so very roughly working on landmass, as in size of continents. Okay, and placing the tropics where the deserts are on the Earth. Now, one thing to bear in mind to any stickler, okay? Deserts are arid regions, okay? They can be arid because of heat, or they can be arid because of cold, okay? But as long as there's no rainfall or very, very low rainfall, that's what an arid region is, a desert, okay? So the Gobi Desert, the Sahara, the Mexican or South American deserts fall on the Tropic of Cancer. And then on the Tropic of Capricorn, you have the Chilean desert and the Kalahari and the Australian desert. Those on the Tropic of Capricorn. Okay, so what I've done is I've basically drawn land masses of approximately correct relative size to each other and place these land masses where the tropics are. And what I found is that you have a pretty much bigger North Pole region, this void in the center where this unfortunate tape thing is on the Gleasons. So this area here is pretty much quite a lot bigger. Okay.
Yes.
So, but I've also shown, and I'm going to show it with two different diagrams. This is very rough and not actually very. This is very rough. This area here is too dark, and that's me shading whilst I was talking to someone. This is a rough layout where what I've done is I've made Eurasia twice the size of Africa, and here's the Americas, and here's Australia. Okay, and this is the night in. This is the dark area is no, sorry. Yes, the dark area is the night, as happens when it's the southern summer. So you see in the north, the area that's covered by nighttime in the circle is longer than the area that is covered by daytime in the day. Whereas in the south, at the same time as this is happening, the daytime is much longer and the nighttime shorter. Now I have the opposite on this map, where I haven't actually placed everything. You see, it's very quickly done. I've not placed everything on the tropics. I've just made these guidelines to see how time works, daytime, nighttime. You see, this circle here, let me see what I'm displaying. Okay, so this circle here, if you carry on drawing this circle, you'll see that this circle in the north, this would be the northern summer. This circle is the area that has light, and this circle is much bigger than the remainder of the circle here. So we have more sunlight hours in the summer. At the same time, the sunlight hours in the south, this curve is much shorter than the rest of the curve, which would be here, which means they have a shorter day in the south and a much longer night. This is basically the equivalent to the other one, where it's the northern summer versus the southern summer. So that's all that I really did. I made Eurasia the size relatively compared to Africa, and Australia also. Well, not so much in the second map. If you go, for anybody who wants to check, or maybe design your own, go spend maybe 10 minutes, 15 minutes online, look at the continent land masses. You'll see that there's differences. It depends where you look. You'll arrive at an average and work on those land masses. The average difference between Africa and Eurasia is just under twice the size. So Eurasia is 21 million miles, whereas Africa is 11.5 million square miles. Okay, so that's not quite twice. You know, Eurasia is not quite twice the size of Africa, but it is much bigger. On the Gleasons, this area is not much bigger. So when you make this area twice the size of this area, now given that both of these are incorrect because they are projections, so they splay out, okay? But on this, if you look here, here's the Arctic Circle, and this is where the Gobi Desert is. Now the Gobi Desert, although it's much colder than the Sahara, the coldness is not due to its proximity to the Arctic Circle. The coldness is due to its elevation above sea level. So you have to bear that in mind. Deserts have the heat of the sun and the elevation above sea level. The higher you go, the colder. And the colder, the more likely there is to be rain. So in the Gobi Desert, there's more rain than the Sahara, and it's also higher. Okay? But you can determine that it's still under the Tropic of Cancer, otherwise it wouldn't have the heat that it has, given its height. So that's all. You just make this the correct size for anybody watching with diamonds on paper. And if you make this the correct size, you can't push this further out towards the Arctic ring, Antarctic Circle. You can't push Australia out, because then you're moving Australia away from the Tropic of Capricorn. So once you've made this bigger, this Eurasia, you have to keep this relative distance to all the other land masses there. And the only way to do that is to move Australia across. Otherwise, you'll be pushing it towards Antarctica. And once you've moved this across, you arrive generally at something that looks like this, or like this, generally speaking, or closer to the Kobayashi map. And then when you include this cool little quirky fact, that this difference, the real world difference between Hawaii and New Zealand is 1 hour, but a completely different day. So the sun, if you were ignoring days of the week, solar noon would happen in Hawaii, and 1 hour later, just about an hour later, it's not exactly an hour, maybe an hour and 27 minutes, but solar noon in Hawaii, and later an hour and 27 minutes or so, solar noon in New Zealand. Okay? But because we have days, it's very easy to lose track and to not know how distant it is, because it's not on the same latitudinal line, it's on a different latitudinal line. So in terms of distance, it's like this. So I'm going to put my fist up, like for Jet Skeptic Media. So you have Hawaii. I hope it's not reversing. You have Hawaii and New Zealand, very close to each other in terms of longitudinal lines, okay, 1 hour away, but this distance across the latitudes makes it difficult for people to determine what the actual time is. And when you arrive at the other country, you've got to change your watch to say it's the next day. And when you go back to Hawaii, you have to change it back to say it's the previous day. So this is where they've used the calendar to distort things, and they've used time, which is obviously related to the calendar, to also distort things. Nathan and I showed this with the differences that they have in the time and date UTC map. So where can they hide this? They can hide it where it's the least populated and the most difficult to keep track of. This region, that's where they can hide it. They can't hide it here. There's a bunch of people there. Can't hide it here. Bunch of people there. Where can they hide it? Here, this region. And this is where they've hidden it. So when you make everything correct.
Cammie's reactions to what you've said, Antonio, but before I do, because this is the first time Cammie's hearing a lot of what you've just presented, I've heard it a couple of times, but I want to, on air, say kudos, and a lot of people have said it in the chat as well, not just to Cammie, but to you, Antonio. You know, what you've done thus far is very, very eye-opening, and, you know, great. I'm going to ask Cammie for her reactions, and then I'm going to come back to you and ask you to read the email, if you will, that you sent to Dr. Zach earlier today, and you'll understand why when I ask the next question after getting Cammie's reactions. So first and foremost, Cammie, what do you make of all that after seeing it for the first time?
I'm still processing. It's good. No, I'm looking at a lot of the things that he's looking at. I also look at things a little bit differently too. Everybody does, and that's what makes it so much fun. And so I'm incorporating it in. I don't know what reaction, or was there a specific? He went through a lot. So when you say his reaction, was there?
Yeah, if I can just coach you a little bit. This is the reaction that I would like to see. Okay. No. It would be diamond map. That. And Nathan is shaking his head. Because that means botifarras in Spanish, in Catalan, which means no, bugger you kind of thing. But just that, and just smile.
I feel like I'm missing all of. I'm missing out.
It's just, this is an expression that means no, we win, we're stronger, we're better.
Antonio, Cammie pays zero attention to the flat Earth drama. She's just, it's just. Am I right in saying this, Cammie? None of this means anything to you.
None of this means anything to me.
Okay, no, well in that case,
I'm going to ask you a specific question though, because it was someone, I can't remember. I'm sorry to credit them. I can't remember who it was that asked. But you were obviously holding up a ball and a flashlight and explaining moon phases.
Mm-hmm.
Do you think the moon is a spherical, physical object?
I believe the moon is a physical, spherical object. I believe it is physical, very much physical up there. I believe it gives off its own light via fluorescence is what I believe. And in trying to make a model, again, when trying to model it, I'm working with this premises that what we see is like what we get. Do you see? I mean, I see it as a round spherical object dropping by, and then as far as like the flashlight and the ball and getting the reflections that you get from underneath, which again, I feel very confident about this because I've been going out every day for over a year now, and I haven't been able to. It's been perfect. Yeah. I mean, some days it's cloudy and I don't get out. You know, it doesn't work on that. But I have not. It's not. I've been tracking for over a year where it is on there and just making sure, you know, before putting out information like that, that there's some accuracy to it. So as far as the moon phases is something, again, it's probably the first piece of the puzzle I picked up. And it's the one I've been working with the longest, and so the way that the quarter moon and the different phases work, I had it about a year ago, except for it was my perspective piece that didn't work, meaning that I felt that if you looked at it from here, you should get this piece of it. When you looked at it from here, you should get this piece. I wasn't bringing the sky down via like your own perspective.
Yes, but it's incredible.
The mechanics on it would not work unless it was a sphere. Unless it was a physical sphere, the mechanics could not work on it Now you don't see the backside of it. You're right. We only see one. So is it a sphere all the way around? Is it like, for instance, is it missing? Is it missing a piece in the back or lopsided or something like that? I don't know.
Not, I mean, we get to see. Is it called libration? Is it? I think we get to see 59% of the sphere.
Right. So, I mean, what I see is I see it as a sphere and I see it dropping down. What the backside actually looks like, if the backside, you know, somehow got damaged, or, you know, I mean, I don't know what the backside looks like, but I know that what we see, I feel, is very spherical.
Yeah.
Yeah, I'd completely agree, and physical as well. I mean, I've certainly had this conversation a few times in Take Back Space's chat room, and obviously there's plenty of people out there that think it's holographic or, you know, whatever. But if you don't mind, Cami, are you okay to read out what you put out? I haven't actually asked you before the show if you were okay to do this, Antonio, so this has dropped you on this at the last moment. I'm sorry.
To do what? Sorry, I was miles away then.
What I was hoping you would do is it's a couple of minutes of you reading, but your email exchange, just the last two between yourself and Dr. Zach in regards to the sun. Read that.
Instead of reading it, because I'll stumble over my words, because I feel all nervous, you know, because so many people are, you know, hanging on my every word. So instead, I'll just kind of condense it.
Okay, cool. That'd be brilliant. Yes, please.
Yeah. This is what it is. Dr. Zach, mega cool dude, really gifted, really freaking bright, okay, and really good with AutoCAD. So he's been watching the sun, and he's been doing all kinds of observations and working with AutoCAD and suncalc.org and verifying readings, okay. And what he's found is that when the sun is overhead, is circling overhead at a point, say on the Tropic of Cancer, that if the sun was basically a physical object in the sky that was moving away from you, then it would move. Now you have what he's saying is perspective does not explain the sun entirely, okay? Because what you would have is you'd have the sun moving relatively quickly past you as it's above you, and they're slowing down in the distance, the same way as cars on a racing track. When they go past you, they're zooming really fast, but when they're on the other side of the circuit, they're moving kind of relatively slowly compared to your point of view. And what he's found is that this doesn't seem to happen. What seems to happen is the sun goes across, you know, at a stable rate, and then at the end kind of seems to speed up just before it goes down. And what he's thinking is that maybe what's happening is the sun that we can look at and triangulate is not where the sun is merely some kind of reflection of where the sun is, which explains how the actual distance to the sun as it goes down to our horizon, it's 6,661 miles away, given its elevation as it moves beyond the horizon at 3.14 miles to somebody who's 6 foot tall. Okay, so the horizon is at one point where the sun appears to go down to us. Given that that's our horizon, so something high up is going to remain above that horizon for a long time. But as he points out, the sun's size is bigger than the 3.14 miles. So you think, hold on, it would take much, much, much longer for it to go down. Instead, it doesn't seem to. It moves across relatively slow throughout the whole of the day, and then at the end, whoop, seems to, you know, just...
I agree, it drops.
Yeah.
Across, especially, we're next to the mountains, and it seems to the very end of it seems to melt in or drop very quickly. I am very, very open. I've noticed I said I thought the moon was a spherical, real object in that, and I'm not going to say if it's exactly where you see it. The sun, I wouldn't begin to say what that is right now, just because I believe I still have a lot of learning to do, you know, before even speculating on it. But I do know that I'm familiar with, like, the refractive indexes and the different properties that you're talking about, and I've very much considered them. You know, is it a firmament? Is it a layer? You know, what are the different layers that you're looking with? One of the things, you know, that I had daily experience doing was testing things and what materials, how much do they bend light? Yes. And
yeah, and what effect that bending has on our
exactly
perception. Yeah. Yeah.
And using that to ID things, and so in other words, we're trying to do it backwards. We're trying to say, well, if it bends this much, it's very easy to measure the bend in something and say, oh, it's got this much of the refractive index is this, and so therefore it must be this, or
Yeah.
But we're doing it backwards, and it's funny that you mentioned that because again, it's one of the things I play with that I'm not ready to really speculate, out there. But I can tell you, I'm a nerd. Girl, and like on doing the different things that we're talking about and coming up with the different, here we'll show you some like different specimens. I should have brought my refractometer and that to play with it, but we have, what do you have?
Ooh,
is it Libyan glass? So the glass that I'm looking at and doing different measurements. I have no idea what the answer is yet. But like that's the desert glass from Libya that people talk about, that the firmament might be made out of.
Or could that be fused by lightning?
That could be fused for lightning. The one thing about this, I would think it would float on it, but the one thing about the desert glass and it being fused by lightning is that the chemical composition of the Libyan desert glass is different than the sands in the area. That's one of the big anomalies on it is that the material is wrong for what should be fused there.
Wow.
But let's say you had a big flood, it got fused somewhere else, and glass floated and dropped down there in a deposit. I don't know. I'm saying that there are a lot of possibilities, but one of the anomalies of the Libyan desert glass is the fact that it does not match up chemically with what should be there as far as if you had the fused glass.
Could it come from somebody who was lost and fell over and broke their torch, and then some corrosion happened?
I think not. I think that the amount of it is huge. You have from outer space the Moldavites.
Yeah. And what is that?
This is Moldavite. It's supposedly, this is natural glass. Volcanic. You have meteorites from Russia. Like when he's saying I have, my husband I think was telling you I have like the collection and that. We're testing all of the materials. We're hands-on testing and having fun. This is a fun science experiment, but we're trying to figure out what, by actually physically looking at, touching, and doing things.
Talking of looking at things, Cami, something that may or may not have passed you by. I hope Bob's put this under your nose. But a YouTuber called Matrix Decode, Ben, recently caught a really interesting, I think it was a high-speed photograph of lightning, and he posed the question, what time of day is this, which is a little bit leading, but it was taken at about 2 o'clock in the morning, and the picture basically showed as looking like the daytime. The sky was completely blue with this one lightning strike, and I've never seen a picture like that. I don't know if did you catch that?
I have not caught it, but I would love it if we can like send it here or drop it in the chat, or...
I'm going to do it right now. I'm going to...
Oh, brilliant! Yeah, I haven't asked him in advance if he minds us sharing us. Please, God, Ben, if you don't mind, let us share your picture.
I don't think he'll mind us sharing at all, and I would urge everybody, if anybody's listening that isn't already subscribed to Matrix Decode, you're missing out, because this guy is a big experimenter. And also, go and view his stuff. I've got it here, Nathan. If you want me to screen share.
Yes, please. If you could do that, that'd be brilliant. Yeah, so definitely like and subscribe to Matrix Decode on YouTube. He does all sorts of fantastic things with mirages, Bedford level experiments, you name it, he does it. You should be subscribed to him if you're a flat earther. Yes.
Okay, so here we are. Okay, if everybody can see this, I'm going to play it muted. Okay. So the question is, what time of day is this? Which is right, because hours happen in days. Even the middle of the night is, what day is it? It's Wednesday, 3 a.m. That's the day. So I'm going to let this play, even though you've just totally stolen.
Well, yeah.
Stolen the thunder, but not the light.
I've stolen the thunder. I was going to not say it. I couldn't think of something else. So you're going to play this out?
Yeah, watch, everybody. Okay, that's what he was actually recording. Okay, the night sky, you see those street lights and everything. He's now slowing down the footage.
It's not playing for me.
Is it not?
Nope. Oh, there we go.
Oh.
There we go.
Yeah?
Yeah.
Okay, let me go back.
Just leave it well alone, I would.
Okay. So this is what 2 a.m. looks like in Spain when there's a lightning flash. This is what happens to the real world. And any of us who've been out when there's been a lightning storm and a lightning flash, we've all seen the world kind of go white, you know, because it's so quickly that our eyes don't have time to register colors, but the camera is not a human eye. So this is what he captured. And that's freaking amazing because it looks like midday.
Actually, Antonio, if you could play maybe the first 25 seconds, because it does show, I think he counts down with 3 strikes being shown.
Okay. Screen sharing, I'm going to make it big. Tell me if it goes big your end, okay, Nathan? Has it gone big?
Yeah, it seems okay. I don't mind if there's a bit of dead air, just so we actually get this on this particular broadcast. I don't mind.
So everybody, please pay attention. I'm going to pause it a second. Pay attention to the shadows under this bush. You see there are actually shadows there. There's shadow on this railing. This light from above is casting shadows, like you'd expect if the light was above. So I'm now back to playing.
Hopefully that gave it a few seconds to buffer.
Yeah, cool.
Dun dun dun. No.
A lightning flash.
We might give up, Antonio. It just doesn't want us to play. But essentially, what? Oh, here we go. No, it's.
Yeah. What he does now is he slows down the speed that he's displaying his video at.
Yeah, we're not getting it. We're just stuck on 4
There you
video
go.
replays, normal speed. Your internet's awful, Antonio. Not to worry.
Well, here you are. We have the actual daylight sky. Are you not seeing it?
Yeah, it's just not playing for the audience or us. Don't worry,
right.
Antonio. We'll give up at that stage, I think, rather than keep going around in circles. We'll put a link to Ben's video in the description box, so you can link to that particular video and like and subscribe to Matrix Decode.
Yes.
How long have we been going? Probably about an hour and 50 minutes. Was there anything else that you wanted to get in there before we disappear and round out the show, Cami?
I'd like to say thank you for having me, and I'd like to maybe do it again more and continue on with it instead of trying to. I know we're short of time now, but I'd love to.
We're not short of time, Cami. I think Nathan's considering you and Jaren, and that you might need to go. But
no, he's right. I do need to go, but I'd like to do it again, and I'd like to. I mean, on the different things, I'd like to say like the Celestine or Celestite, because I know that what I did was I threw out a lot of information fast.
Yeah.
And like with all, here's the whole world, here it is, da 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 da. But each one of the little facets has got a lot of stories and things behind it, or a lot of reasoning behind it that could be good, could be bad, but regardless, I'd like to put it out there because if any of it's bad, I trust the community will let me know, or let my husband know or that. But, as we're working on it, it's been a very, very busy time. I think for a lot of people, fall is busy. It's back to school for, getting the kids and the things like that. And Flat Earth is, again, it's my biggest hobby in the world and my love in the world, but it's not all I can't do it all day long every day, and I wish I could, but it's not possible. And so everything just needs to go on small pieces, and the map is coming really, really good. I want to let you guys know. I've been working on the map. What I'm doing on the map and what you would call working on it are probably 2 different things, because I don't have any pictures to show or anything like that. What I do is I sit there I measure and I graph and I make adjustments and I make notes on the layout. But I've been collecting a lot of data and putting it all together, and I'm not having any big problems or any big issues or anything that's not, I have not come across anything that's really, what we would call a map killer, and so I'm very, very optimistic with that.
Yeah, cool.
To say the least.
So
yeah.
would you, not to kind of cross-examine you, but would you, from what you've seen, does it look like the map will be kind of similar to what I showed, which is similar to the Gleasons, but with adjustments to, relative adjustments for landmass? Or would you say it's very, very different, where the actual lands are?
I would say it's very similar. In other words, you need to correct for the size of the distances, and you need to correct, and your main thing is it doesn't change the look of it so much as you just need to change the way that you read magnetics.
Yes.
But the actual layouts in that are not so different. There are a few little pieces that are out on any given one that maybe I'm not there yet, but I'm still fine-tuning on mine. I want to thank everybody that sent me information. People have sent me pictures of, sunrises, sunsets, 24-hour days. I've really been overwhelmed with, in such a good way, good feedback and things to consider. It's a double-edged sword. I get caught on reading all of the stuff, so I'm not doing the research. I try to stay out of any of the politics and that. I don't have time for it. I need more time.
I said to Patricia today that I'm going to do the same. I'm going to leave all of the politics and all of the backbiting and all kinds of stuff. I'm going to leave that totally aside. If I take anything out on anyone, it's going to be Nathan.
Well,
what I will say is I will add a link in the description, not just to Ben's video of that lightning, but also to the video of the Skype conversation that we had, which was also titled "How the World Works," and we get to see you on full guns blazing, all 12 cylinders firing. It was
very excited. Yes.
It was brilliant. So that's got a lot of the information. So if you've heard terms like Celestite, Celestine, or wanted a bigger version, if you like, even though it's coming at 100 miles an hour, but Cami does go through things like the phases of the moon, explains about Celestite potentially being the material that it's made of, all of those sorts of good things on that particular video, and that'll be in the link in the description below. So in the meantime, thank you, Cami Nodal, for being on Mechanics of the Fourth Wall. You've been an absolute superstar, so thank you very much indeed.
Thank you for having me. That's sweet. I don't feel like a superstar, but that's very, very sweet.
But what you said about...
you are. And we'll add one more thing. When you talked about being a merman, just being... That's so important for people to realise that we are all just regular folk, from you all the way through to Math Powerland, Jaren from Jeranism, and your son. We're all on the same page, we're all the same type of people. We're all just doing regular stuff in our days and obsessed with flat earth in our nights. So there we go. I'll also say a big thank you to Antonio Subrats. Was there something you wanted to add, Antonio? There usually is.
Yeah, yes, I need the toilet. No, that wasn't it. Cami, you said that we could do this again, and I think that's a really good idea. The beauty of this kind of format that Nathan and I discussed, this Mechanics of the Fourth Wall, so we can discuss anything about the real world because everything has been hidden. So it might as well be stuff that's behind the fourth wall. But because we have this fluid format, we don't stick to the same day of the week or the same time, or have rules and stuff. We tend to prefer people to be on camera just because it makes it more visually pleasing to the observers when the camera's not on me. So I think it's cool, if you come back on in a week or 2 weeks or whenever, even if we've just finished doing a Mechanics of the Fourth Wall, yeah, sure, we'll do another one with you and discuss things further. Because people are interested, and I will say to people out there, what Cami's doing, she spent a lot of time thinking and then a lot of time compiling real world data. But the real world data is out there, and Nathan and I have had a lot of people saying, "Where's your data from the sun tracking?" It's like, well, dude, the data from the sun tracking is in that 24 hours of continuous hangout. Go there and tabulate it. Go there, sit through it, and do it yourself, because it's like they're saying, thanks very much for that. Now we want you to do more things for us. We can't be asked doing it. You do it. It's like, no, you do it. So, sorry, that's a little rant.
No, I like that rant, actually. It's a good one.
I think it would be really good if anytime that you think, hey, I've come to another realization, or I've noticed something, should we discuss it? Just like we can discuss it off air, just between us, we can discuss it here. even if it's just hashing things out, because some people in the chat will be saying, oh, dude, I think this is going on, and we might pick up on that and go, this person says this might be going on. I hadn't thought of that. And we're a group being. We're a communal. We're what's it called?
We are Borg.
Yeah, no, we are a social animal, okay, and we grow through interaction with others. That's how information passes on. A person in a cave learning all kinds of stuff about the universe might as well not be learning it unless he's passing it on to other humans. So contribution and sharing, that's part of this. This is what Nathan was saying. We're all the same kind of people who like to share, like to learn, and like to pass on. We don't want prestige, we don't want glory, all that.
I'm going to here and say the opposite of that is nicely described in the last 2 minutes of what you said as hidden. And I think on the first show we were all talking about the occult, and it's the same thing. Things that are occulted are simply hidden from us by the elites that Cami mentioned, and this is what it's all about. This is what we want to talk about on this particular show. And on that note, I'm going to say another massive thank you to Cami Nodal for being on Mechanics of the Fourth Wall, and of course Antonio Subirats. And to all of you who have joined us live and have been chatting away quite happily in the chat, thank you very much for joining myself, Antonio Subirats, and Cami Nodal. I've been Nathan Oakley. I'll see you all in the next video.